this lesson, we're going to do two things. First of all, we're going to introduce you to the concept of a storage area network. We just call it a SAN. And then we're going to look at one implementation of a SAN called ISCSI. So let's start off by spending a few minutes talking about what a SAN is and how it works. Let's take a look at a standard non-SAN server deployment. In this type of deployment, we just basically have the server box itself. And inside that server box, we have all the various components. We have the motherboard, memory, network board, and so on. And within the server, we have some type of storage device implemented. And we've shared information on that storage device so that clients can access it. For example, we might define a shared folder on this storage device. We have client systems over here that access the server over the network and are therefore able to access the contents of this shared folder, save data to it, read information from it, whatever their permissions allow them to do. Now, implementing a server in this way has a lot of benefits, namely in the form of cost. This is relatively cheap to implement. It also has some serious drawbacks. It has many points of failure. For example, let's suppose that this server goes down in this scenario. Maybe we have a bad memory module. Maybe the CPU overheats and melts down. Something bad happens to this server. If this happens, then this workstation over here loses access to the shared storage on the storage device in that server. To remedy this situation, we can implement what's called a storage area network. Now, in a storage area network, we have multiple servers that all share a common storage device. Notice in this example, instead of having one server with one storage device, I have 4 servers all sharing the same storage device. Now, because they all share the same storage device, the failure of one of these servers does not necessarily mean that the data on the shared storage device becomes unavailable to our client systems over here. Now, in the previous example, the failure of one server system did make the data on the storage device become unavailable to clients. But in this scenario, that is not the case. Let's say that we have a client here and it's going through this server to access a shared folder on this storage device. And something bad happens to this server. Maybe, again, the CPU overheats, melts down, server goes offline. Well, in this scenario, that's not as big of a deal because we have 4 servers all accessing the same storage device. So instead of going through the first server, this client can be redirected to go through the second server and have access to the very same shared folder on that storage device. The fact that the first server went down does not cut off access to the information in that shared folder. Now, this is done by implementing some type of clustering software. With clustering software, these servers know how to take over for each other should one go down. Basically, these servers all exchange heartbeat packets with each other. And if these other servers in this cluster notice that a heartbeat packet does not arrive from one of the cluster members, then it knows it's down, and then a computer algorithm is used to decide which one is going to take over for the server that failed. Now, in order to do this, we essentially have to define 2 separate networks. Notice that I have a network segment up here that is my standard production network. It probably uses Ethernet hardware. It's the network that my client systems over here use to access my servers over here. But notice I've also implemented a second network down here. This is my SAN network. Sometimes we call it the SAN fabric. It's a separate, dedicated network. You'll notice that my workstations are over here on my production network. There are no workstations on my SAN fabric. The only systems connected to the SAN fabric are my servers and my shared storage device, nothing else. It's dedicated to doing nothing but storage. Now, this means that each of these servers actually has 2 network cards installed, at least 2, probably more, but they have to have at least 2. One for the production network and one for the SAN fabric. Just as our production network up here probably has a switch implemented somewhere that all these stations connect into, our SAN fabric probably also has some type of switch implemented that all of the storage devices and servers connect into. So basically, we just have 2 separate networks. One is just used for production traffic, and the other one is just used for storage traffic. Now, understand that this is how a SAN works conceptually. There are actually many different ways in which a SAN can be physically implemented. There are 2 commonly used SAN technologies that you should be familiar with. The most expensive of the 2 is called fiber channel. And yes, that is how it's spelled. Sometimes we just abbreviate it as FC. There's also a less expensive option called ISCSI. Now, regardless of which technology we choose to use, fiber channel or ISCSI, they function in basically the same way. We have a production network that connects servers to workstations, and we have a SAN network that connects each of the servers to a shared storage device. The difference really is the type of technology down here used in the SAN fabric that connects the servers to that storage device. The key difference between these two is the fact that Fibre Channel uses Fibre Channel hardware. You have to use Fibre Channel network boards, you have to use Fibre Channel switches, and you have to use Fibre Channel cabling, and it's very, very expensive. I mean, really, really expensive. The benefit of iSCSI is the fact that instead of using very expensive Fibre Channel hardware, it just uses standard off-the-shelf Ethernet hardware to create your SAN. Now, Fibre Channel probably does provide a lot better performance than iSCSI, but the price difference is dramatic. You can get almost as good a performance with iSCSI, but a much, much, much lower cost. You can basically set up your iSCSI SAN just by ordering a standard Ethernet switch, standard Ethernet NICs, and deploying a standard Ethernet network. So let's take a look at how iSCSI works. Now, over here, we have a server. This is a device that needs to connect to our shared storage over here. So if I have, say, an application running over here on this server, and it needs to write data to the shared storage device over here on the right, it's going to go ahead and perform an I/O operation. Now, normally what would happen is that I/O operation would be sent to the appropriate locally attached storage device, like a locally attached SATA hard drive or SCSI hard drive or whatever. But in this case, something special is going to happen. We actually have iSCSI software running on the server, and it knows what to do when data needs to be written to this shared storage device. Instead of sending it to a locally attached storage device, what it does is take that I/O request and encapsulate it into an IP packet. And then instead of sending that I/O request to that locally attached disk through its SCSI board or through its SATA interface, we instead forward that IP packet through the network interface in the server, through my SAN fabric, where it arrives at the shared storage device, which notice also has a network interface installed in it. That IP packet is decapsulated, and from that packet we extract the I/O request that was initiated over here on the server, such as to write data to the hard drive, and it actually gets written to the shared storage device. So when you're dealing with iSCSI, I want you to just mentally draw a line like right about here. Above this line, we're dealing with the SCSI block protocol. This is the same protocol that's used whenever you have a SCSI locally attached disk and you write or read information from it. Below this line, however, we're talking Ethernet. So essentially, we're mixing SCSI with Ethernet to create iSCSI. Now, before we go any farther, there are a couple of iSCSI related terms that you've got to understand. The first term you need to be familiar with is the iSCSI initiator, and the other one is the iSCSI target. Here's what you need to understand. Your servers over here using iSCSI use a logical entity called an iSCSI initiator to connect to and communicate over here with the iSCSI target, which is basically the shared storage device. So the initiator is the device connecting to the shared storage. The shared storage itself is the target. The cool thing about this configuration is that the storage devices over here on the remote iSCSI target appear to the local operating system on the iSCSI initiator or server over here on the left as if it were a locally attached hard drive. If you were to open up File Explorer, you would see the iSCSI target shown right there as if it were a locally attached disk, but it's not. It's located out on our SAN fabric. And the key thing to remember is that multiple initiators can connect to that same iSCSI target, not just one server. So we could have 5, 6, 7, 8, 10 different iSCSI initiators all connecting to one single iSCSI target over here. That allows us to create a SAN fabric, and that allows us to create a cluster of network servers. Now, a quick word of warning. Because iSCSI uses standard Ethernet hardware, sometimes there's a temptation to not set up a dedicated storage network using Ethernet hardware, because some system administrators who are cheap, like me, think, well, hey, I've already got this Ethernet network up here. Why do I need to set up a second one? Let's not set up a dedicated Ethernet network just for storage. Let's just go ahead and attach our shared storage up here to our production network, right? It'll save us all that time and expense of setting up a dedicated SAN fabric. Well, can you do this? Yeah. Is it a good idea? No, it's really a dumb idea. Think about it. Your production network probably gets hammered all day long. If you have a lot of workstations and a lot of servers all using that production network, then you're not going to have a whole lot of bandwidth left over to have a shared storage device up here connected to it. Think about it, if your users are streaming online video, if they're streaming music, if they're saving big files back and forth, then your storage network traffic is going to be contesting with that standard production network traffic, and you're going to get lousy performance. And performance is the key for making a storage area network work. Because if you think about it, what we're doing is replacing a locally attached disk with a SCSI target out on the network. So we need to have excellent bandwidth between the initiator here and the shared storage device over here. You're not going to get that if you connect that shared storage device to your production network. So if you're going to implement iSCSI, do it the right way. Create a dedicated Ethernet network just for your storage devices, and then install a second network board into each of your servers and use that to connect to your shared storage. You'll get much better performance. That's it for this lesson. In this lesson, we introduced you to iSCSI SANs. We first talked about what a SAN itself is. Then we discussed how a SAN can be implemented using off-the-shelf Ethernet hardware using iSCSI.